A, right. How many people are in the histogram? So if you go through, like I said, when you get a histogram, start trying to read and label everything because you're going to need it at some point. That's 3, looks like 7, 6, and 4. So there's 10, there's another 10, so that should be a total of 20 in the histogram.
You just got A wrong.
That's why I go back and check my work. What is the greatest possible average that could have produced this histogram? Okay. What is the greatest possible average? So let's look at what is possible to produce this histogram. It is possible that all 3 of these people weighed at the very highest end of this interval. It's possible that all of them weighed 149. Yes, it's possible. Not likely. But we're talking about the greatest possible average. So if we want the greatest possible average, then we want all of these people to be have the greatest amount of weight within that interval. So it's possible that all of them weighed 49. It's possible that all 7 of these weighed 179. If they were 180, they'd probably, no, not 179, 174. If they were 175, then they'd be right on the line. We could say 175, because what do you do with those that are 175? Which category do they go in? It doesn't really say. I won't go in both. You got to count in one or the other. This one, these 6 could weigh 199. All 4 of these might weigh 225. And so we go back and do the same thing we did on the previous problem when we use the midpoint of each of those sections. 3 times 149 plus, and you keep this in your calculator, and then you can come back and change some of the numbers as you need. But 3 times 149 and 7 at 174 and 6 at 199 and 4 at 225. And then we add all that up and divide that by 20, and we should get the largest average that could represent, that still could be represented by this graph. We don't know how much these people weigh. It is possible, at the very most, that they would have an average similar to whatever we get when we calculate here. I got 187.75. It's possible it could be a little higher than that. It could go up to 188, maybe even 188 and a half. If all of these were not just 149, but what if they were 150? What if they're at the very edge, 175 and 200 and 225? Yeah, I put 225, not 224. But it's possible that you could go a little bit higher than that, because we're not quite to the very edge of that interval. But somewhere between 175 or 187.75, so around 188 would be about the biggest average. But that's average. So then in the next problem, it says the least possible median. All right, well, what is median? One in the middle. How many do we have? We have 20. So we're not going to have a single person in the middle. We're going to have to average person number 10 and person number 11. So let's just think about person number 10 and person number 11. And we want the smallest possible average between those two values, because that's how we're going to have to find the median. We're going to have to average the two in the middle. So I want those two to be as low as possible to give me the lowest average between those two. So what is the lightest that person 10 could possibly weigh? 150. It's possible that how many did I have? 7 of these would be right at 150, maybe 151. But it's possible that all of them ended up being on this edge as opposed to the upper edge. And if that was the case, if all of them are right here, and one of these in this group of 6 was right here, if that was number 11, too many dashes there. Okay. And this number 10 ended up being right there, then if 10 weighed 150, and person number 11, when they're all in order, weighed 175, then 150 plus 175, 2, that would be about as low a median as we could hope for. Because that would be the lowest that the 2 people in the middle could be. Then part C, what is the best estimate of the average? So we're back to, instead of finding the extreme of any of these intervals, we go back to the midpoint. Now that may take a little calculator work, because we're going from 125 to 150. What's halfway between 125 and 150? And I know he knew that right off the top of his head. But that's what we will use. We'll have that times 3 plus, was that 162.5? Times 7.
187.5.
So we're using the midpoint of each of these intervals.
And then 212.5.
And then we come back in and get a total and divide the total.
176.2.
So when you're doing the best average, you go for the middle. You just use the midpoint of each of those intervals. However many are in that interval times the midpoint of that interval. Now, what's the best estimate for the median? Because the median's not influenced by how many are in one side, how much they weighed. Is this a weight? Yeah. Because if I want the best estimate for the median, then I want the average between number 10 and 11 again, but I want to put number 10 and 11 right in the middle of their interval this time. So if I put number 10 and number 11 right in the middle of each of their intervals, then I'm right at 175 when I average those two. If I take 162.5 and 187.5 and average them, I end up right at 175. Okay. Number 6. So I need to decide if I can get away with using the 68, 95, 99.7 rule. Because the z-score chart will work, but it's a little bit more work. So here's how I can test whether this is going to work in my 68, 95, 99.7 rule. So I start with this middle, 24.8 K, all right? And then I'm going to step off by 800ths. So that'll be 25.6, 26.2, 2, 4, and then 27.2. If I go this way, 3 steps, each step is 800 or 8.8. I get 24, 23.2, 22.4, and 21.6. Already did 3. Never mind. Already did 3. So, are any of these questions asking about those numbers specifically? 24.8, 25.6. Oh yeah, 24.8, 25.6. 22.4 and 25.6. 22.4, 25.6. 24.8, yeah. 22.4, yeah. 24 even, yeah. So since these are asking about those numbers, I can go to that 68, 95, 99.7 rule bell-shaped curve, and it has all my percentages right there. Okay? So you got that handy? Anybody got that handy? So on that curve, you have these breaking points. And in your notes, you have all of the percentages right there in front of you on your notes. You should have all of them there. So if it wants 24.8 to 25.6, then we've got only between those two, what percent is on your paper in between those two? 34. 34. It goes 34, 34, I can't remember.
13.5.
And then 0.15, 0.15. All right, so we wanted between 24.8 and 25.6, 34%. We want between 22.4 and 25.6. 22.4 is right here. 25.6 is right there. So I'm going to add those four numbers together. 2. What do I get? Should be 83.85, I think. I'm just saying because I've got 50 here, plus 34 is 84, but I'm not using that, so 84 minus the 0.15 should be 83.85. Or I can just add them up. Depends on how much I can do in my head. What percent is less than 24.8? So from here over. Now how many of you would add all four of those numbers up? Most of you. Don't lie. That's the middle. Well, how much you think is less than the middle? 50. It's half. It's 50%. You can add them up if you want. At some point, you gotta get with it. 50%. More than 22.4. 22.4 is right here. Well, that's pretty much everything except for this. So that's 100% except for that. 99.85. That's just 0.15 away from 100. More than 24,000. Okay? Okay, that's all of that. Well, that's half plus the 34. 50 plus 34. So you can go ahead and add all five numbers up if you want. 84. So if you did it on the z-score, it would be a little bit more complicated. You'd have a little bit more places that you would run into mistakes, but you should still end up with close to the same numbers. Always.
Struggle to teach a math class.
Not the math, it's hard to teach kids.
Sure about that? It's not.
Math is easy to teach, kids are hard to teach. Last 20 years. Distribution of the cholesterol of women 50 to 59 is approximately normal. I mean, it's bell-shaped. With an average of 223, standard deviation of 43.8. What percentage of the women have a cholesterol level less than 23.9? Okay, 22.3 to 23.9 is not a standard deviation jump. So I'm not looking at numbers that are one standard deviation jumps away. So I'm going to be like in halves of standard deviations, and so I'm going to have to use Z-score. I'm going to have to use Z-score chart. So my average is 22.3, standard deviation is 43.8. What percent of women less than 23.9? So whatever percentage I find is going to give me the percentage less than. So my number, my value is 239. My average is 223. I divide that by 43.8, and I get what? 0.3652. So take that over to your Z-score chart. So 0.3652. If we go to the Z-score chart and find the Z-score of 0.3652. 0.3652. The Z-score column, not the proportion column. 0.36 would be closer to 0.4. This would be my proportion, which would shift to 65.54%. That's my Z-score. That's equivalent to 65.54%. That is the percent below, which is what they asked. Less than. Okay, and that's approximately. So this is approximately 0.4. Now, none of this is exact, because even though these bell-shaped curves are symmetric, they're not perfectly symmetric, but they're relatively symmetric. How many would you expect to have a cholesterol level greater than 200? So remember that when we find, let's just think through this. We can find the percent less than 200 by doing it the same way we did A. But it asks for the percent greater than 200. So we're going to need to remember to subtract that from 100. Because the percent we find is going to be below that. We need the percent above that. So 200 is going to go into as my value. I'm still going to subtract 223. I'm still going to divide by 43.8 because the average and the standard deviation didn't change. What does that give me as a Z-score? Okay, so probably a negative 0.5, which would be somewhere around here, which correspond to a 30.85% below. So if I have 30.85% below, and I want greater than, I need above, that would be approximately 69.15% above. These
subtract from 100. Those two should add up to 100, I think they do. Okay, and one more. What? No, I subtracted from 100. From 100, because that's the percent below, that'll be the percent above. So if there's half of them below you, there's half of them above you. If there's 30% below you, there's 70% above you. If there's 2% below you, there's 98% above you. If there's 0% above you, then you are the best.